Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. Today we're going to be covering Unit 7, Lesson 5. Today's lesson is all about compound interest. Of course, don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Our objective today is I will model using compound interest to show exponential growth. Mastery will be demonstrated by scoring at least 80% on the extra practice. So compound interest is a type of exponential growth. So we're still talking exponential equations. We're still talking exponential growth. Our variables will still be an exponent for these functions. So the compound interest equation that you're always going to use is A is equal to P times 1 plus R divided by N over N to the T. So this time what's happening is instead of our regular exponential growth equation, which was like y is equal to a times b to the x, and we would use x as time. We used for b, we would use 1 plus r. So we're still taking 1 plus r, but we have to divide the rate, the growth rate, by n. And I'll explain what n means in just a second. And then x is still like representing time, which is in our exponent, but we have to represent the time by n as well. Alrighty, so it's still an exponential growth equation. It still follows the same format, except we're dividing the growth rate by n and we're multiplying the time by n as well in our exponent. So what do each of these things represent? So when you see A represents your total amount. So your new total after a given time. P represents your principal balance. And I can never remember which principal it is, if it's principal like that or principal. And I think it's pal, so I'm gonna write it like that, but I might be using the wrong one. I don't know, not a good speller. So the principal amount, which is also known as your original amount. Which is the same kind of language we used when we talked about exponential growth in the first place. Then R is still your growth rate, the rate at which your money is growing. N is the number of times per year. And I'll explain that in just a second. And then T is the time. And when we talk about compound interest, the time is usually in years. And usually we're talking about like money in an investment account growing over a certain amount of time. And that time is in years. So when I talk about N, the number of times per year, you're gonna see language in each problem that you're gonna wanna look for. You're gonna wanna look for it annual, semi-annual, quarterly, and monthly. So how many times per year does annual mean? Annual means once a year. Semi-annually means twice a year. Quarterly means 4 times per year, and monthly means 12 times per year. So what we use for N here is going to depend on the words annual, semi-annual, quarterly, monthly, etc. Okay. So let's just jump right into an example. So $1,000 is left in a bank savings account. So $1,000 is left in a bank savings account, drawing 7% interest compounded quarterly for 10 years. What is the balance at the end of that time? So again, our equation is A is equal to the principal times 1 plus the rate divided by N to the N times T power. So I highlighted the important information. Your initial amount, your original amount is $1,000. So we're gonna plug that in for P. You have 7% interest, so your rate is 0.07. It's compounded quarterly, so N is 4. And for 10 years, so T is 10. So we're gonna plug that information into our compounded interest formula. So that's gonna look like A is equal to 1,000 times 1 plus 0.07 divided by 4, all to the 4 times 10 power. So you're gonna have to be really careful how you plug this into your calculator. The first thing I like to do is I like to go ahead and just take 4 times 10, which is 40. So we're gonna be taking this to the 40th power. All right, so let me show you how to plug this into a calculator. This is what I recommend you do. So the first thing I would do is I would deal with the 0 divided by 4. So we're going to 0.07 divided by 4, sorry. 0.07 divided by 4. Then we're going to add 1 to that. So the first thing I'm going to do is take 0.07 divided by 4 and I'm going to add 1 to it. And the reason why I want you to do this in this order is, notice I'm not rounding that decimal. I'm going to keep that decimal as it is. So we've added 1. So we've added 1. Now we're going to take it to the 40th power and then multiply by 1,000. So I'm going to hit caret, and it's going to take my previous answer of 1.0175, and I'm going to take that to the 40th power. I'm going to hit enter. Then I'm going to multiply that by 1,000, the original or the initial amount, which is 2001.59734, etc. We're talking about money though, so we want to round to the nearest hundredths decimal place. So our final answer is going to be, let me move this out of the way, 2001.597. So we're going to round that to 60. So after 10 years, the account will have $2,001.60. So that means that our original amount of $1,000 doubled in 10 years, and we didn't even have to do anything to it. We didn't add money to it. We just let it sit in an account by itself and let it grow. This is the magic of compound interest. All right, so let's go to the next problem. I want you to go ahead and try example 1B on your own. You lend out $5,500 at 10% compounded monthly. If the debt is repaid in 18 months, what is the total owed at the time of repayment? So I'm going to highlight your important information. $5,500, 10%, compounded monthly, and 18 months. Here's a hint though. When we talk about time, we talk about time in years. You need to change 18 months to years. How many years is 18 months? All right, go ahead and give this problem a shot on your own and tell me what you get for your final answer. Okay, so if you plug everything in correctly, you should have changed 18 months to 1.5 years, multiply that by 12. Don't forget to divide your interest by 12 as well. You should have gotten 6,386.12, but we're talking about money. So I want to make sure that I have my units labeled of money or dollars. So after 1.5 years, the amount owed will be $6,386.12. Okay, so now we're going to do something a little different though. We're going to find the principal amount given the new total. So this time, instead of finding A in our equation, we're going to be looking for the original amount or the initial amount. Okay, so what principal will amount to $3,000 if invested at 3% interest compounded semi-annually for 10 years? So the important info here is we have $3,000 for our new amount, 3% interest compounded semi-annually in 10 years. So that means that this time A is 3,000. Our rate is 0.03. N would be 2 for semi-annually, and T would be 10. So let's set up our equation. So our equation is going to look like 3,000 is equal to P, we don't know what that principal was, plus 0.03 divided by 2 to the 2 times 10 power. Yeah, T was 10. So all I did was I took our equation, A equals P times 1 plus R over N to the N times T power, and I plugged in what I know. I know A, I know R, N, and T. All right, so now we have to solve this equation for P. So here's what we should do. We're going to take 3,000 is equal to P times 1 plus 0.03 divided by 2 to the 2 times 10, which is the 20th power. So to get P by itself, P is being multiplied by this. So that means to cancel it, I'm going to divide both sides by 1 plus 0.03 divided by 2 to the 20th. And I'm going to divide this side as well. What I do to one side, I have to do to the other. And that'll cancel on that side. So P then will be equal to whatever 3,000 divided by 1 plus 0.03 divided by 2 to the 20th. So we're going to very, very, very carefully plug this into our calculator. And let me walk you through what to do. So here's what I would do when you plug this into your calculator. The first thing I would deal with is your denominator. So if you have a calculator handy that works similar to mine, make sure you follow these steps. So we're going to take, actually, I'll show you what to do this way. We're going to take 3,000 and we're going to divide it by, and you're going to put parentheses. You're going to put 2 sets of parentheses. So parentheses, parentheses. In the inner parentheses, you're going to put 1 plus 0.03 divided by 2. And then you're going to put caret 20 and then the rest of your parentheses. So that way your calculator knows order of operations. It's going to deal with the parentheses first. So your calculator will take 0.03 divided by 2 first, then it'll add 1. It'll take that to the 20th power, and then it'll take 3,000 divided by all of that. And this way it avoids us rounding and causing a rounding error. So now we want to wait to round until our very final answer. So our final answer then is that our principal balance was $2,227.41. So that means 10 years ago, the initial amount invested was $2,227.41. And in 10 years, that amount grew to $3,000. Kind of cool, huh? All right. So why don't you go ahead and do example B on your own? What principal will amount to $1,750 if invested at 3% interest compounded quarterly for 5 years? So just follow the same steps we did before, plug this into your formula, solve for P, and make sure you plug it into your calculator correctly. I'll see you on the other side of this problem. Go ahead and give it a shot. So 5 years ago, $1,507.08 would have been invested in this account for it to grow to $1,750 in those 5 years. Now we need to talk about something called compounded continuously. So as you can see in the last 2 word problems, they have the words compounded continuously. So compounded continuously uses a slightly different formula than compounded interest. So instead of using this equation, whenever you see compounded continuously, you're going to use this equation. And that equation is A is equal to P times E to the RT. So anytime you have compounded continuously for your interest, your growth rate or your growth factor is E. E is your growth factor. And E is actually a natural number. So E is a natural number. And what I mean by natural number is that it's naturally occurring. And in a regular school year, I would actually walk you through how to derive the number E so you can see where it comes from yourself. But for now, you're just gonna have to trust me that this number does exist. It's a naturally occurring number. So the number E, in fact, I'll show you what the number E is just using a calculator. If you hit second and then your LN button, the number E should pop up for you on your calculator. And if you plug in 1 for the exponent, so you take e to the first, you'll see that E is the number 2.71828182885. So that is what the number E is. And we use that as our growth factor with compounded continuously accounts. So A is still your new amount, what your account has grown to over time. T is still your time, and we use time in years. P is still your principal balance or your initial amount or original amount, whatever words you want to use. And R is still your growth rate. So instead of having to calculate 1 plus B over N, or 1 plus R over N, sorry, you just use the number E instead. So I'll show you what this looks like. So a bank is offering a CD that pays 6% compounded continuously. How much would a deposit of $2,000 earn over 8 years? So we're going to take A equals P times E to the RT. Our principal balance is $2,000. Our rate is 6%, so 0.06. And T, our time, is in 8 years. So we're going to plug this in. A is equal to $2,000 times E to the 0.06 times 8. All right, that's a little multiplication simple. So let's plug this thing into the calculator. I'll show you how. If I can open my calculator app, that would be helpful. All right, so you're going to take 2,000, put it in parentheses. Then you're going to take second, and that LN button should bring E up. On my calculator, E to the X is right above that LN button. Then for the exponent, you're going to put 0.06 times 8, and then hit enter. And you get 3,232.15. We're still talking about money, so we're rounding to the nearest hundredths place. 3232.15. And then because it's a word problem like we've been doing, we're going to write our final answer as a complete sentence. So in 8 years, the CD will be worth $3,232.15. All right, continuing on. So now I want you to do the last problem on your own. You receive a gift of $5,000 and want to invest it. How much will the gift be worth in an account paying 4.5% interest compounded continuously? You receive a gift of $5,000. And I forgot to give you time. Let's say in 10 years, plug 10 in. All right, go ahead and find how much that account will be worth in 10 years. So hopefully our answers match. I found that the account will be worth $7,841.56 in 10 years. All right, make sure you go do your extra practice and let me know when you're done with it. I'll see you back in class.